What do you know about generative AI? AI is not just a buzzword. It's a powerful tool that's shaping our present and future. From understanding languages and creating art to transforming industries, AI holds strong potential. In this video, we're going to break down what AI is, how it works, and how it's set to revolutionize businesses and society at large. Whether you're curious about AI's history, intrigued by its current capabilities, or want to learn how it can benefit your business, you're in the right place. Watch the complete video to understand the importance of generative AI in business. Arthur C. Clarke once said, "Any sufficiently advanced technology is indistinguishable from magic." The first time you experienced generative AI might have felt like witnessing magic unfold. For the first time in history, we have a technology capable of not only understanding our languages and requests, but also producing completely novel creations. Generative AI can write poetry, craft otherworldly images, generate code, and even surprise us with original jokes or musical compositions. Its ability to create from seemingly nothing often evokes wonder. Yet, AI is far from magic. It is, at its core, a complex amalgamation of math and science, and its development was not an overnight event, but a process that took decades of research, experimentation, and refinement. AI is poised to touch every aspect of our lives and change the world in ways both big and small. Yet, how exactly AI will reshape our future is largely up to us as a society. It's up to us to decide how we use this powerful tool to improve businesses, enhance lives, and address the challenges of our time. A brief history of AI. The fascination with machines that could potentially think traces back to the late 1800s. However, the idea of machines truly simulating human cognition found its footing with Alan Turing's groundbreaking work in the 1950s. Turing is often referred to as the father of AI. In his seminal 1950 paper, he theorized that machines could eventually surpass human capabilities in activities such as playing chess or processing natural language. He even speculated that machines could one day think. Thanks to the efforts of researchers, especially those at institutions like IBM, many of the milestones Turing predicted have been reached. IBM's chess-playing computer, Deep Blue, famously defeated world chess champion Garry Kasparov in 1997. Later, IBM's Watson system made headlines when it triumphed over human champions in the quiz show Jeopardy! And developed AI systems capable of debating. But Turing's vision was only the beginning. While his 1950 paper laid the conceptual groundwork for AI, the field truly began to take shape with the Dartmouth Workshop in 1956. This meeting, organized by a group of academics and researchers from Bell Labs and IBM, is where the term artificial intelligence was coined. The participants laid out many of the challenges that AI researchers have been working to solve ever since, such as developing machines capable of self-directed learning, creativity, and more. Hardware evolution and AI's transformation. The year 1956 was significant, not only for the birth of AI as a formal field, but also for technological progress. It was the year the transistor was invented, which later earned its inventors the Nobel Prize. Transistors revolutionized hardware, providing the foundation for the modern computing era. Today, we can have over 100 billion transistors on a single GPU. And with interconnected banks of GPUs providing enormous computational power, we can now run sophisticated AI models like generative AI. These models are the result of decades of parallel progress in AI theory and hardware capabilities. As the cost of computing and storage has dramatically decreased over the years, AI has become more practical and accessible. However, it's crucial to understand that AI's success isn't just due to powerful hardware and innovative algorithms. The third, often overlooked, ingredient is data. You can't talk about AI, particularly generative AI, without discussing data. AI models are built on vast amounts of data, which they use to generate insights and make predictions. Large language models and generative AI. A term you've likely heard in recent discussions around AI is large language models, LLMs. But what exactly are these models? And how do they work? At a basic level, LLMs represent language in a high-dimensional space, using billions or even trillions of parameters. These parameters are learned by training the model on massive datasets, often composed of large quantities of text from the internet, and other sources. In many ways, the history of computing has been a series of innovations in how we represent and work with data. Initially, we stored data in tables, rows of customers, columns of attributes, in databases designed for transaction processing. This method worked well for tasks like payroll or payment processing. Later, we started representing data as graphs, allowing us to map relationships between people, businesses, and places. This graph-based representation helped in identifying patterns, such as spotting fraudulent transactions. Now, with LLMs, we've advanced to neural networks that mimic the structure of brain cells, with layers and layers of connections. These models, with billions of parameters, are capable of learning incredibly detailed patterns in data. For example, they can predict the next word in a sequence with high confidence, create entirely new sentences, generate novel images, or even produce music. This is what generative AI is all about: discovering relationships within data and using that knowledge to generate new content, whether it's text, images, sounds, or any other form of data. The rise of self-supervised learning. The journey to generative AI was not immediate. For years, deep learning, a significant milestone in AI, allowed us to train neural networks on vast amounts of data. However, early deep learning models required labeled data annotated by humans, to guide the learning process. This approach, known as supervised learning, is expensive and time-consuming. As a result, only large institutions could afford to build and train these models, and the models were often designed for very specific tasks. A breakthrough occurred around 2017 with the development of a new architecture called transformers. Transformers enabled a different kind of learning: self-supervised learning. In this approach, a model is trained on large amounts of unlabeled data, learning to fill in missing information, such as predicting masked words in a sentence. This process, when scaled up, leads to powerful representations, which we now call large language models. These models aren't just specialized for one task, they're adaptable and generalizable. They can be trained on massive datasets and then fine-tuned for specific applications, making them versatile across a wide range of use cases, foundation models, and their impact. The result of self-supervised learning at scale is what we now refer to as foundation models. These are large-scale neural networks trained on enormous amounts of data, and they serve as the foundation for a variety of downstream tasks. Businesses and organizations can take a pre-trained foundation model, tune it with their own data, and quickly deploy AI solutions that are customized to their specific needs. The versatility of foundation models raises an intriguing question: what exactly is a language? In AI, language isn't just about human speech. It's any set of signals or data that can be deciphered and understood. For example, the signals from industrial equipment, user clicks on a website, software code, and even the molecular diagrams in chemistry are all forms of language. AI can be applied to these diverse fields, making it possible to boost productivity across a wide range of tasks. The future of AI, utopia or dystopia. With the rapid advancements in AI over the last few years, we've come full circle from the ambitions of the 1950s. Today's models aren't yet true general intelligence, but they can pass the Turing test, the famous measure of a machine's ability to exhibit intelligent behavior indistinguishable from that of a human. This raises an important question: what does the future hold for AI? Some people view generative AI as the dawn of a utopian age, while others fear it signals the prelude to a dystopian future. I take a more moderate view. Both optimism and anxiety are valid responses. The same questions have been asked at every major technological milestone, from the Industrial Revolution to the rise of the Internet. AI's impact will depend on how we choose to use it. AI is not just about the digital world. Its applications extend into the physical world as well. Properly applied, AI could accelerate discoveries in fields like medicine, energy, and climate science. It has the potential to address many of the pressing challenges we face as a global society. However, to realize this potential, we need to approach AI responsibly. It's essential to protect our data, ensure transparency, and address ethical concerns. As AI becomes more ingrained in business and society, decision makers must have the knowledge to guide its development and use. It's not enough to be a passive AI user. We must become active participants in shaping its future. In the next chapter of the AI story, the future will not be dominated by one or two models that do everything for everyone. Instead, AI will be multimodal and democratized. Through open science and open source AI, everyone will have a voice in what AI does, how it's used, and how it impacts society. Now is the time to start planning how you can effectively, safely, and responsibly put AI to work in your business and in your life. This means understanding the technology, protecting your data, and ensuring ethical AI practices. While you don't need to become an AI expert, it's crucial to have a strong foundation to make informed decisions about how this powerful tool will shape the future. Thanks for watching the full video. Be sure to subscribe and hit the notification bell so you don't miss out on the next video. For more information about AI in business, be sure to visit www.judafmarketing.com.